And today I'm going to show you how to select the correct statistical tests when comparing groups or time periods. Okay. I've developed this test selection matrix that contains the most popular statistical tests used for comparing groups and time periods and also for exploring relationships and prediction. Okay. So we have the independent samples t-test for comparing groups, the dependent or paired samples t-test, the one-way ANOVA, the two-way ANOVA, repeated measures ANOVA, mixed design ANOVA, analysis of covariance, chi-square test of goodness of fit. And then for exploring relationships or prediction, we have the bivariate correlation, the bivariate linear regression, the multiple linear regression, the binomial logistic regression, multinomial logistic regression, factor analysis, reliability analysis, and chi-square test of independence. So if you are interested in obtaining this test selection matrix, just type in interested in the text box below in the chat area. Just type in interested, okay? And I will contact you via Messenger and I will send it to you. Now, if you also need assistance with selecting the correct statistical test, or you want somebody to take a look at it and make sure you did the right thing, you can contact me for that as well. And finally, if you need someone to help you run the test, you can contact me and I'll show you how to do it. All right. So let's start with part one, which is statistical test for comparing groups. I'm just going to take about 5 minutes. And then part two will cover exploring relationships. All right. So before I begin, really quickly, my name is Jacob Mays. I'm the founder of SPSSvideotutor.com. And since 2008, I have helped over 1,100 students, doctoral students, analyze their data for their dissertation and successfully achieve their doctorate degree. Okay, so this is what I do for a living. This is not something, I don't drive an Uber, I don't go to work. This is what I do full time. All right, so let's start. The independent samples t-test. This is appropriate when you want to compare the mean scores between two groups. You have one categorical variable containing two groups and one continuous variable. So let's say, for example, we want to compare classroom 1 and classroom 2 on math scores. Okay? Math scores are scored on a 0 to 100 scale. Okay, classroom 1, so class would be the independent variable, and then we've got two groups, classroom 1 and classroom 2. And this is the dependent variable, math scores, and it's scored on a continuous scale. All right? So we would use an independent samples t-test for this scenario. All right? All right, next. We've got the dependent or paired samples t-test. Applies when you have one group of subjects or matched pairs where data is collected from this group over two different time periods or conditions. So you've got one categorical variable with two time periods, one continuous variable measured on two different conditions or time periods. All right, so let's say we've got classroom 1, right? And we've got time 1 and time 2. So we have the math test, math scores at time 1, we call this the pre-test. And then time 2 would be the post-test. Okay, so this would be at the beginning of the semester, and this would be at the end of the semester. So class would be time is the independent variable. We have time 1 and time 2. The dependent variable are math scores, because these are the continuous variables that are scored on a 0 to 100 scale. Okay, so time is the independent variable because there are two time periods, time 1 and time 2, and we're measuring the same class both times, right? That's why we call it paired or dependent. Here we were measuring class 1 versus class 2. That's why it was independent. This is dependence because we're measuring the same people twice. Okay? All right. Now, here we've got the one way between groups ANOVA. Assesses whether there are differences in the mean scores between 3 or more groups on a continuous variable. One categorical variable with 3 or more time periods, 3 or more categories, okay? 3 or more categories, 3 or more groups, one continuous variable. So here we had 2 groups. We had class 1, we had class 2. Now we're adding a third, class 3. And we're comparing mean score, math scores 0 to 100 on all 3. And we're seeing if there's a significant difference between class 1, class 2, and class 3. Now, if we were only looking at class 2, then we would just look at the independent samples t-test. Class 1 and 2, we would look at this. But since we have 3 or more, then we have to use the one-way ANOVA. Okay? All right. Next, the two-way factorial ANOVA. So whenever you see 2 in front of the word way, that means the number of independent variables. So if you see a 3-way, that means you have 3 independent variables. 4-way, that means you have 4 independent variables. But here we just have 2. And it says allows you to simultaneously test the effect of 2 or more variables on a dependent variable. So you have 2 or more IVs that are categorical. It's very important. Your IVs, when you're comparing groups, always have to be categorical. Your DV has to be continuous. It's either interval or ratio scale. So let's say our first IV is class. Independent variable is classroom. All right, just like it was before. We've got classroom 1, classroom 2, and classroom 3. Right? Then we've got so this is IV1. And then we've got IV2, which is teaching approach. So we've got new math, and then we've got traditional. Okay? So new math is one approach, traditional is another approach. All right? So now what we have is this. We've got new math and then traditional. Right? So we've got classroom 1, and then we've got classroom 2, okay? And then we've got classroom 3 and classroom 4. All right? So 2 classrooms have new math and 2 classrooms have traditional math. All right? So we've got 2 independent variables. So this would be classroom 3 and this would be classroom 4. All right? So just so we could have it even. So the IV1 is classroom, IV2 is math instruction, type of math instruction. Okay? MI, math instruction. All right? So that's the way this is done. When you have 2 independent variables, then you run a two-way factorial ANOVA. Oops. Let me just, this line is a little crooked. All right? So then you would run a two-way factorial ANOVA. All right, next. You have a repeated measures ANOVA. So repeated measures ANOVA is the same thing or similar to the dependent samples t-test. The only difference is you had 2 here and you use this when you have 3 or more. So originally we had time 1 and time 2, right? When we did the dependent or paired samples t-test. But now we're going to have time 3, right? So we've got classroom 1 is measured at time 1. So this is the pre-test. Classroom 1, same classroom, is measured. We're going to call this the midterm. And then classroom 1, same students, we're going to call this the final. Okay, same test over 3 different time periods. Same people, same test given at 3 different times. Same people, same test, 3 different times. Okay, that's what we're doing here with the repeated measures ANOVA. And it's 3 or more time periods. All right. Next, we've got the mixed design ANOVA. Here, we're combining both the between subjects and the repeated measures. So this is how it would work. You would have 2 variables, 1 categorical variable containing at least 2 groups, 1 categorical variable measured at least 2 levels of repeated measures or 2 time periods. So we got class, we've got class, right, is IV1 and IV2 is time. Got to have at least 2 time periods. So we've got class 1 and class 2. And then we have the pre-test for class 1, and then we've got the post-test. So this is time 1, this is time 2, pre, post, time 1, time 2. So not only are we comparing class 1 versus class 2, we're also comparing within the classes time 1 versus time 2 for both of these. That's why we call it a mixed design, because it mixes repeated measures and between groups measures. Okay. And then we have what we call the analysis of covariance. And the analysis of covariance is an ANOVA, but you have a controlling variable. So let's say, for example, we want to compare math scores between classroom 1 versus classroom 2. But we think that classroom 2 may have smarter kids, right? So it's going to be biased. So what we would do is we would have a control of IQ scores, right? So if we controlled for any pre-existing abilities, then we could compare class 1 versus class 2 when they're more equalized, right? So this equalizes the groups to remove any bias based on previous ability. So then we can compare class 1 versus class 2 without bias in skill, previous skill. Okay? That's what we call the analysis of covariance. And then finally, we have the chi-square test of goodness of fit, used to compare the proportion of cases from a sample with hypothesized values or those obtained previously from a comparison population. You have 1 categorical variable with 2 or more categories, and you have a hypothesized proportion. Okay? All right. So here, what we're trying to do is we know that in this entire state of Florida, 63% of the students pass the math test across the entire state. So we want to compare if students in class 1 do better than the state. So we have 10 students, right? So you got 10 students. Okay. And you say, okay, how many of these students passed? Right. So you got 10 students in the class, and we're going to say 7 passed. So what we would do is we use a chi-square goodness of fit to determine if 70, so 7 out of 10 is 70, if 70 is significantly higher than 73. That's what you would use to determine a chi-square goodness of fit. All right. So this is part 1. We've covered how to select the correct statistical test for comparing groups or time periods. If you want the test selection matrix or you need help selecting the correct statistical test or performing the correct statistical test, just type in interested below. I'll reach out to you and I will send this to you, and we will go from there. All right. Hopefully this was helpful, and part 2 will be tomorrow. All right. Take care. Much success.